September 14th, 2020, a team of astronomers at Cardiff University picked up something in their data that made them stop breathing. They were studying Venus, our nearest planetary neighbor, a world we have largely ignored for 50 years, and buried inside the spectral readings from its cloud layers was a chemical signature that on Earth has only one reliable source: life. The chemical was phosphine, a molecule made of phosphorus and hydrogen, and according to every model scientists had, there was no geological process, no lightning storm, no volcanic reaction on Venus that could explain its presence, which left only one conclusion that no one in that room wanted to say out loud. Something might be alive up there, in the clouds of hell. This is Dark Chapter, and today we are going somewhere no documentary has taken you before. Not just to the surface of Venus, but deep into its past, its clouds, and the terrifying future it might represent for Earth itself. Stay with us, because this story gets darker before it gets fascinating. Let's start with what Venus actually is, because most people know nothing about it, and that ignorance is frankly dangerous. Venus is the second planet from the Sun. It sits between Mercury and Earth. In terms of raw statistics, it is Earth's closest relative in the entire solar system. Surface area, nearly identical. Gravity, 90% of ours. Mean distance from the Sun, comparable. If you were floating in deep space looking at both planets side by side, you'd think they were siblings. But they are not. Venus is what planetary scientists call a runaway greenhouse world, and to understand what that means in real physical terms, let's talk about what your body would experience if you stepped onto its surface without protection. In the first fraction of a second, the atmospheric pressure would hit you. Venus carries a surface pressure of approximately 92 bar. To put that in human terms, that is the equivalent of being submerged 900 meters below the ocean surface. For context, the deepest military submarine in service, the Russian K-329 Belgorod, is rated to a maximum depth of 600 meters. Venus's atmosphere would destroy it. Before your bones finished fracturing from the pressure, the temperature would register 465 degrees Celsius. That is not a number for dramatic effect. That is the point at which lead melts, at which zinc becomes a liquid, at which certain grades of aerospace steel begin to soften. The surface of Venus is hot enough to melt most metals. And if somehow you survived those two simultaneous death sentences, the clouds above you would be raining sulfuric acid, not water, acid, concentrated enough to dissolve organic tissue on contact. Crushed, incinerated, dissolved simultaneously. This is Venus, our neighbor, our twin. And yet, it wasn't always this way. 4 billion years ago, the solar system was young. And according to climate simulations run by NASA's Goddard Institute for Space Studies, Venus may have been something extraordinary. It may have had liquid oceans. Those simulations, run by researchers including Dr. Michael Way and colleagues, published in Geophysical Research Letters, modeled early Venusian conditions and found that Venus could have sustained shallow liquid water oceans for up to 2 billion years. 2 billion years. Let that number anchor in your mind. On Earth, in 2 billion years, evolution moved from single-celled organisms to complex multicellular life, from bacteria to jellyfish, from nothing to everything. If Venus had 2 billion years of stable liquid water conditions, the mathematical probability that nothing biological ever took root there is not zero. And then something broke it. The most widely supported hypothesis involves catastrophic volcanic resurfacing. Approximately 500 to 700 million years ago, Venus appears to have experienced a global volcanic event of unimaginable scale. Geological data from the Magellan spacecraft, which mapped 98% of Venus's surface between 1990 and 1994, shows a planet almost entirely resurfaced by volcanic activity. There are over 2,600 major volcanoes identified on Venus. Some are still potentially active. Here's the chain reaction that followed. Volcanic activity pumped massive quantities of CO2 into the atmosphere. CO2 is a greenhouse gas. Temperatures rose. Rising temperatures caused the oceans to evaporate. Water vapor is also a greenhouse gas, so more water vapor meant more warming, which evaporated more water, which created more warming. A self-amplifying loop, a feedback spiral with no off switch. Scientists call it the runaway greenhouse effect. And once it started on Venus, it never stopped. Venus went from paradise to hell in, cosmically speaking, a blink. If there was life on Venus before that event, microbial, primitive, whatever form it took, it had no warning. It had no escape. The extinction of Venus may be the greatest catastrophe in our solar system's history, and almost no one talks about it. You are now standing at a real moral intersection that scientists and ethicists are actively debating. Venus may have once harbored life. A runaway greenhouse effect wiped it all out. And right now, Earth's CO2 levels are rising faster than at any point in the last 800,000 years, according to NOAA ice core data. Here's the dilemma. If we had definitive proof that a past civilization on Venus knew their planet was dying and chose not to act because the changes were too slow, too expensive, too politically inconvenient to address, what would that prove about intelligence as a survival trait? Drop your analysis in the comments. This is a dark chapter discussion. We want to hear your actual reasoning, not just opinions. Now let's return to 2020 and that phosphine signal. Professor Jane Greaves of Cardiff University led the team that first detected phosphine in Venus's atmosphere using the James Clerk Maxwell telescope. In Hawaii and the ALMA array in Chile, the initial data suggested concentrations of approximately 20 parts per billion in the cloud, layers at altitudes between 48 and 60 kilometers. The scientific community erupted. Not with celebration, with skepticism, which is exactly what you want from good science. Follow-up analyses in 2021 suggested the original signal may have been partially contaminated by SO2, sulfur dioxide, reducing the estimated phosphine concentration significantly. The debate continues to this day. The signal has not been confirmed. But critically, it has not been explained away either. Because here is the forensic problem that no one has solved. Every known non-biological source for phosphine on Venus has been tested and found inadequate. Volcanic outgassing, insufficient by several orders of magnitude. Photochemical reactions from sunlight, those would actually destroy phosphine, not create it. Lightning, again insufficient. Meteorite delivery yachts insufficient. The signal is anomalous. And anomalous in science means the answer hasn't been found yet, which brings us to a concept called extremophiles. On Earth, we have organisms that survive in conditions that should be impossible. Thermus aquaticus, first discovered in Yellowstone's hot springs, thrives at 80 degrees Celsius. Deinococcus radiodurans can withstand radiation levels 1,000 times the lethal dose for a human. Ferroplasma acidiphilum, found in mining drainage and in the Rio Tinto River in Spain, lives comfortably in pH levels approaching battery acid. Venus's cloud layers at 50 kilometers altitude sits at temperatures between 0 and 50 degrees Celsius, at pressures similar to Earth's surface, with abundant chemical energy available from the sulfuric acid environment. The conditions are brutal, but they are not categorically more extreme than what extremophiles on Earth routinely survive. Could something be alive in those clouds right now? The honest scientific answer is, we don't know, and we won't know until we go back. Here is something most people don't know about Carl Sagan. In 1967, the same year, NASA was still reeling from the Apollo 1 fire that killed Gus Grissom, Ed White, and Roger Chaffee. Sagan and his colleague, Harold Morowitz, published a paper proposing that the cloud layers of Venus could support life, not on the surface, in the clouds. That paper was largely dismissed at the time. Venus was a strange, hostile, embarrassing mystery, and no one wanted to engage with it seriously. Decades later, Sagan's instinct looks like prescience, because those same cloud layers he identified as potentially habitable are now the central focus of NASA's next generation of Venus missions. NASA's Da Vinci mission, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, will drop a probe through Venus's atmosphere in the early 2030s, directly sampling the very cloud layer where phosphine was detected. The Veritas mission, Venus Emissivity, Radioscience in SAR topography, and spectroscopy, will map the surface in unprecedented detail, looking for evidence of geological activity in ancient ocean basins. The European Space Agency's Envision mission will study both the surface and atmosphere in parallel. 3 separate missions, all converging on the same question. The question Sagan raised 57 years ago: is something alive in the clouds of Venus? Here is the chapter of this story that should keep you awake. Venus is not an alien world. Venus is a warning. Earth's current CO2 concentration, according to NOAA's Mauna Loa Observatory, crossed 420 parts per million in 2023. The last time Earth's atmosphere held that much carbon dioxide was over 3 million years ago, when global sea levels were estimated to be 15 to 25 meters higher than today. On Venus, the CO2 concentration is 96.5%. That is not where Earth is headed in any near-term human timeline. Let's be precise about that. The runaway greenhouse effect that consumed Venus required specific conditions: a closer orbital distance to the Sun, the loss of a magnetic field, and extraordinary volcanic activity that do not perfectly mirror Earth's current situation. But here is what Venus does prove, categorically and without scientific dispute: a planet that has liquid oceans, a stable temperature range, and conditions hospitable to life can, through atmospheric chemistry alone, transform into a world where metal melts and no organic material survives on the surface. It is physically possible. We have a case study. It is 108 million kilometers away, and on a clear night, it is the brightest object in your sky after the moon. The ancient Romans named it Venus, the goddess of beauty. They did not know they were looking at the most lethal object in the solar system. They could not see what was burning inside. Before we close this chapter, here is your analytical challenge. Venus tells us two things simultaneously. First, that a neighboring planet may once have harbored life, which would make life in the universe far more common than we currently assume. Second, that a hospitable world can self-destruct through atmospheric feedback, and we are currently running the opening acts of that same mechanism on Earth. The question isn't whether we should care. The question is this: if humanity confirmed microbial life in Venus's clouds tomorrow, would that discovery make us more serious about protecting Earth, or would we use it as psychological evidence that life is resilient enough to survive anything we do to this planet? This is a dark chapter moral dilemma. Comment below with your honest analysis. We read everyone. Venus has no moon. Think about what that means in human terms for a moment. Earth's moon has stabilized our axial tilt for billions of years, keeping our climate within the narrow band that allowed complex life to evolve. Mars has 2 small moons, barely more than captured asteroids. Venus has nothing. It rotates in the wrong direction, while every other planet in the solar system spins counterclockwise when viewed from the north. Venus rotates clockwise. A Venusian day, one full rotation on its axis, lasts 243 Earth days, longer than its year. On Venus, the sun rises in the west. A full day-night cycle takes longer than a full trip around the sun. And when the sun does finally set, the temperature doesn't change, not by a single degree. The greenhouse effect is so total, so absolute, that the distinction between day and night has become thermodynamically irrelevant. There is something deeply unsettling about that. A planet where darkness brings no relief. We do not yet know if Venus once held life. The missions scheduled for the 2030s may finally answer that question. If they do, if even microbial biosignatures are found in those cloud layers, either living or fossilized, it will be, without qualification, the most significant scientific discovery in human history. Not because of what it tells us about Venus, because of what it tells us about the universe, about how common life might be, about what happens to it when planetary conditions shift, about us. Venus is the closest thing our solar system has to a warning letter from the cosmos. Beautiful from a distance, blindingly bright in the night sky. Something the ancients called a star and poets called a goddess. Burning alive from the inside. This has been Dark Chapter. If this investigation opened a new line of thinking for you, subscribe and let the algorithm know this conversation matters. The next chapter goes somewhere darker still.